Okay, the first is, if you take the nth root of a to the power of m, the order that you apply these doesn't matter. The radical and the powers are both contained in the same step of the order of operations. They're both contained here in the exponent form, and you'll see with the next section when we rewrite radicals as rational powers that it's just another way of writing an exponent. Okay, so if you take the nth root of a to the m, it doesn't matter whether you take the nth root of a all to the m, or if you take a to the m and then take the nth root of that. Both of them are going to yield the exact same answer. Okay, and so where this might come in handy is if you did something like this. Okay, if you saw the square root of 25 cubed, okay, and I told you need to solve this without a calculator. And some people might try to multiply 25 out times itself 3 times, and then you're going to get stuck because you won't know the square root of that. Okay, but if you apply the square root first, so if we reorder this as the square root of 25 cubed, what does the square root of 25 simplify to?
5.
5 cubed is. Okay, so you can do this by hand without a calculator if you apply this particular property. All right, the rule of taking 2 radicals with the same index. Again, the index has to be the same. The bases can be different, but if you multiply 2 radicals with the same index, you can combine their product underneath one common radical. That radical will have the same common index, but you can combine the product of a and b inside. Okay, so again, if you're looking at how you could simplify this, the cube root of 7 times the cube root of 3. Okay, as long as the indices is the plural for index, so as long as the indices are the same, you can combine that product under one common radical, 7 times 3, to give you your simplified form of cube root of 21. Okay. The same property holds true with division of 2 numbers with the same index. So the nth root of a over the nth root of b, as long as the indices are the same, you can combine them into one single fraction. That fraction will have the common index applied to the entire thing. A over b will be contained within that radical. And so, once again, if you have something set up where you're looking at the cube root of 25 over the cube root of 5, and you're looking to simplify this, you can, if your indices are the same, you can rewrite that as one single radical. Combine your fraction 25 over 5 inside that radical, and then simplify. 5 goes into 25, leaving 5. Okay. The last property before we get to the property that causes the most confusion is if you embed a radical within another radical. So if you take the nth root of the nth root of a, and so you're applying a radical to a radical, you can simplify this into one radical. The base, the number that's inside the radical, isn't going to change, but the index will. If you take a radical of a radical, you can take the product of their indices. So m times n would be the new index for this. So once again, if you had, like, let's say, the square root of the cube root of 7, you would simplify this. Your base is going to be 7, and your index is going to be the product of these two indices. And when there's nothing written, the unwritten number is 2. So 2 times 3 gives you 6. So that would be the simplified form of that radical. All right, questions on that? Okay. The last property is the one that I'll spend the most time talking about, and that is if you take, and it's one that we looked at before, if you take the nth root of a to the n and you simplify this. Anytime the index and the power are the same, it reduces to just the base itself or the absolute value of that base. And what I'm going to talk about here in just a sec are just some examples and steps to go through to determine which of these forms that you're going to use. And this will be something that, again, I don't think anybody has been exposed to in their previous classes, but it will be a point of emphasis here, and is also, like I mentioned, a point on the final that many students miss. They have the right answer, except they either have an absolute value when they're not supposed to, or they're missing an absolute value when it should be there. Okay? And so, again, that's the downfall to a multiple choice test, is you could have everything exactly right, except you forgot to put absolute values and you have the wrong answer. And so I want you to be really careful